Question number 38. A ray of light is incident on a transparent glass slab of refractive index 1.62. The reflected and refracted rays are mutually perpendicular. The angle of incidence is A 58.3, B 50, C 35 and D is 30 degree. So let us take a medium separating a boundary separating two medium. A ray of light is incident and let this be the normal and this is the reflected ray. So this is the incident ray, this is the reflected ray, then this is the reflected ray. Now they are telling this angle is 90 degree. If this is angle of incidence, by the angle of reflection, if this is I, this should also be I. So this is R. So now I is not given, but I and R can be calculated now. Let us say this is I and this is I, this is R. So this total angle from here to here should be equal to 180 degree. So if angle of incidence equal to I, angle of refraction should be equal to, see, it should be equal to 90 minus I, because I plus 90 plus 90 minus I will have 180 degree. So this is a 90 minus I. So mu is equal to sin I by sin R. Mu is equal to sin I by sin R. Now in this case we can use this as a sin I by sin R is a sin of 90 minus I. Sin 90 by 90 minus I is cos I. So we can now write this as, now how can we write now this one as a sin I by cos I. Sin I by cos I is tan I. So this is a tan I. So see this is equivalent to cos I, remember. So mu is equal to tan I. So I is equal to tan inverse of mu. What is mu? It is a 1.62. So I is equal to tan inverse of 1.62. So it is a not 1.62. Simply it is a tan inverse of 1.62. Now we know that tan 45 equal to 1, tan 60 is a 1.732. So it should be less than 60, no, but more than 45. So answer is 58.3 exactly. If you calculate tan inverse of 1.62 is 58.3.